I think a lot of groups are busy gathering data, integrating data, making it available for research, and I think this is fantastic because we need that. We're now at a time when we can make good use of it. I think what also deserves attention, and maybe that's the future in 5-10 years, is the focus on how to analyze the data and how to maintain quality and derive valuable research through that. Thinking about the needs for big data, I identified 5 areas, and what I'm certain is the list is incomplete. But the ones we are focusing on right now, one is comparative effectiveness methodology, which is basically how to design studies. This enables us to analyze non-randomized experiments in a meaningful way. The second one is around using electronic health records data. These are available, they are the founding block of many of the systems that are being aggregated. So it's critical to understand the potential uses and benefits, but also the limitations of EHR data. Then there is machine learning, which stormed into clinical research and many other domains with a lot of success and a lot of promise. But it needs to be adapted for applications into clinical research. Then there is predictive modeling. Basically, you can say that every research question is about how to risk stratify your patients or to decide who will benefit from one therapy versus the other. And then pragmatic clinical trials. We need randomized experiments, but we need to do them more efficiently and work around designing better studies, but also monitoring and running and executing better studies can be helped by quantitative methods. I think we need the fusion of the old and the new. We need the fusion of traditional biostatistics and quantitative epidemiology with novel methods like machine learning. I think both fields bring, on one hand, very helpful insight, history and potential for the right study design, and machine learning enables us to solve problems that we were not able to solve before. So when you combine them, I think that's where the true power of clinical research will be realized. I am very excited about the fusion of machine learning, biostatistics, and adapting the existing machine learning algorithms from binary and count data to implement them for time to event, continuous predictors, and building risk prediction models of the future. I think it's a great time to be a biostatistician or data scientist at large, because I think the potential is tremendous, and as the fields are moving more closely together and fusing together, I think great things are ahead of us.